Welcome. In this video, I'm going to show you how to compute some additional probabilities. So suppose there are 15 labeled marbles. Each label consists of the numbers 1 through 15. Let event A be an odd number is drawn, and event B is a number greater than 6 is drawn. So let's go ahead and describe the sample space, event A and event B. Well, the sample space is all the numbers 1 through 15. Event A only includes the odd numbers, and event B only includes numbers greater than 6. And notice this does not say greater than or equal to, so we're going to take numbers strictly greater than 6, so that's 7 and above. Next is part B. Part B, we're going to compute the probability of event A. Event A has 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 successful outcomes out of the 15 total outcomes. As a decimal, we have 0.5333. Next, let's look at the probability of event B. Event B has 1, 2, 3, 4, 5, 6, 7, 8, 9 successful outcomes out of our original 15 outcomes. This can be reduced to 3 out of 5, and as a decimal, we have 0.6. Next, let's compute A and B. So the probability of event A and event B. So in order to compute this probability, we need to figure out first what is actually inside of A and B. And I'm using the mathematical intersection symbol. That means intersect, and it stands for and. Well, let's see. A has odd numbers, and B has numbers greater than 6. That means event A and B has all odd numbers that are greater than 6 in common. So that's 7, 9, 11, 13, and 15. All right, so the probability of A and B is equal to the 1, 2, 3, 4, 5 successful outcomes out of our original 15 outcomes. As a decimal, that gives us 0.3333. Next, let's look at the probability of A or B. So again, I'm going to begin by looking at what is contained in the set A or B, and I'm using another math symbol here. I'm using this cup to represent the word or. So it looks like we can use all the numbers from event B, and we don't want to double count numbers. So I'm not going to take this 15, it's already taken into account, or this 13 as it's here, this 11, this 9, and this 7. They're all here. So I need to take all the I need to take all the outcomes in event B and then connect those, or that is put in 1, 3, and 5 in there. So A or B is 1, 3, 5, 7, 8, 9, 10, 11, 12. Let me move this for a little more space. 13, 14, 15. This is event A or B. And we have to be very careful with language because A and B includes these items. A or B includes these items. They're not the same. So don't interchange and or. And if I've done that in a video, I apologize. This is A or B. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total successful outcomes. So there are 12 total successful outcomes possible out of our original 15. And you always want to reduce these. You notice I've been reducing these fractions wherever possible in each example, and I can reduce this one to 4 out of 5, which is 0.8 as a decimal. Next, let's compute the probability of event A given B. So this is the probability of drawing an odd marble, given that we've already drawn, this has already occurred. We've already drawn a marble greater than 7. So on the first draw, imagine that you've already drawn a marble greater than 7, and now what is the probability of drawing one of these marbles? Well, remember, this is the probability of A and B divided by the probability of B, and we can compute this as follows. The probability of A and B is 5 divided by 15. And notice I'm taking the unrounded version. That's on purpose because the probability of B I can use with a 5 in the denominator here. Otherwise, if I use the reduced one, to be just a little more work. So I'm going to go ahead and write 9 divided by 15 here. And this just becomes 5 over 9. As a decimal, this probability is 0.5555. Next, let's look at the probability of B given A. So this is 2 draws in a row. Assume we've already drawn an odd marble. What is the probability of drawing a marble greater than 7? So again, we have the probability of A and B in our numerator, divided this time by the probability of A. So we want to divide by the probability that the particular event has occurred. And again, the probability of A and B is 5 over 15. The probability of A is right here at 8 over 15. So this is 5 over 8. As a decimal, this is 0.625. So now I want the probability of the complement of B. And remember, the complement of B can be denoted as B with a bar. And that's everything that is not inside of B. Well, inside of B, we have the numbers 7 through 15. So the complement of B has to be the numbers 1 through 6. The probability of the complement of B, that's equal to 6 out of 15, which is 2 out of 5, and that's 0.4 as a decimal. Okay, now we want to finish this last problem. That is, we want to sum the probability of B with the probability of its complement. Well, the probability of B unreduced was 9 over 15. The probability of its complement was 6 over 15. This gives us 9 plus 6 divided by 15, which is 15 divided by 15, which is 1. The fact that we got 1 tells us that we computed these probabilities correct, since the probability of an event and its complement always have to add up to 1. And we showed that these do add up to 1. We could have also done this using the decimal values. So the probability is 0.6 plus the probability of the complement, which is 0.4, and this becomes 1.0, which is just 1. One caution here, if you're computing something like this and you've rounded these probabilities, you might end up with something that's kind of close to 1, but not exactly 1 due to rounding. And if you go back and add the fractions, you're certain to get something that is 1. I hope you found my video helpful.